All right, so we're looking at the quantum mechanics today. Really, just the quantum world being very, very small, subatomic. Um, and we talked about in the last video, you saw that there was more than just protons, neutrons, and electrons. There's things called quarks. And so we're just going to talk a little bit about subatomic particles in two different videos. We'll see how they're divided up, and we'll make this quick. So, particle physics studies. You guessed it, subatomic particles. Uh, until physics, typically students only know about protons, neutrons, and electrons. Those make up the bulk of the most consistent subatomic particles. But there's actually over 200 different subatomic particles that they found out there. And then they started to look at those 200 and to classify them just like scientists do. They looked for ones that were made up of others and which ones could be broken down. And we found some that were what we call fundamental. So this whole page, we're going to be looking at fundamental particles. Fundamental particles are ones that do not break down into, well, it's not that they don't break down, they're not made up of other particles. Okay? So, what are they? First that we're going to look at are what are known as fermions. Yes, we get to learn all kinds of weird science words today. Um, Fermions are subatomic particles that have what are known as a half spin description. That is different than what is called a boson, which is what we're going to study on the second half of this page, that have an integer spin. That's not, it's a description of an attribute. It's not like they're actually spinning halfway. Um, it's just another, it's like a descriptive thing for the subatomic particle. Our chart here is going to be small subatomic particles on the left, and they're going to go to larger on this side. And let's see here. We're going to have, fermions, we're going to divide into two different ones. We're going to talk about quarks, which is what the last video was about. And then we have what are called leptons. Leptons are actually your smallest subatomic particles. They have a charge. Quarks have a charge of 2/3 and negative 1/3, which you saw that in the video. Leptons have a charge of -1 or 0. So the main ones that we deal with are the up quark and the down quark. Those make up our protons and our neutrons, and two up quarks and one down quark make a +1, so that's a proton. One up, two down makes a 0 charge, so that's our neutron. And then we get our electron, which is actually a subatomic particle. It's a lepton. And what is something called an electron neutrino. So neutrino, that's just very, Star Trek likes to use that word a lot. We call all of these generation 1. Okay, and then there's a generation 2 and a generation 3. Now the thing with generation 2 and 3 is that these typically do not last very long. They decay down into either there or there very, very quickly. Once they reach generation 1, these are kind of everyday and they kind of hang around for a while. Which is good because we like our atoms, we like our protons and neutrons and electrons to all be there all the time. If they randomly disappeared, that'd be weird. Life would change quite dramatically. So we have our up and down, which are generation 1. We have our charm quark and our strange quark that are generation 2. And we have the top and bottom quark, which are generation 3. Now again, they don't last very long. They decay into the previous generations. Just like the electron for generation 1, there is what is called a muon. And of course, its friend, the muon neutrino. And then we also have the tau and the tauon neutrino. These are all just subatomic particles that are fundamental. What's interesting is quarks are never alone. Leptons can be alone, and that's the difference. One of the differences between quarks and leptons. Leptons can be by themselves. We can have just an electron, but we can't have just an up quark. Up and down will always be together in a proton or a neutron type situation. Fundamental forces. This is where we get to the boson. So fundamental particles that aren't broken down we split those into fermions, which are the half spins, and bosons, which are integer spins. Okay. Boson are related to the fundamental forces of the universe. If y'all remember from way back in science, that is gravity, the electromagnetic force, the weak force, and the strong force. Where do we see these forces? We see these forces in mass, if we're talking about Newtonian physics, or gravity is just everywhere when we're talking about general relativity. Electromagnetism, we see that with lights and magnets. The weak force, we see that in radioactive decay. And the strong force, this is what holds the nucleus of an atom together. So this is what holds the quarks together. The protons. Ever wonder why protons, those positively charged protons, aren't repelled by each other? Well, it's because the strong force is stronger than them, stronger than that repulsion, and glues those protons and neutrons together. So the distance that these forces act upon is interesting. Gravity, we know, can stretch out forever. I mean, the sun pulls the earth, and that's forever away. That's an infinite distance. Now, as distance increases, the force gets less, but it does affect over an infinite distance. Electromagnetic is the same way. It's weaker. Gravity is weaker. Electromagnetic is a little bit stronger, but it declines faster. Weak force, we're talking times 10 to the negative 15th meters, and same with the strong force. So that's very much inside the atom subatomic level. Now, what's interesting with the bosons, these are what is called the force carriers. We saw this with light. Light is carried on what is called a photon. That's a subatomic particle that carries light or magnetic energy. With the weak force, we have the W and Z boson. With the strong force, that is carried on the gluon boson, and that literally glues them together. And I skipped one here because it's the graviton, and as far as I know, I haven't been reading much this year on subatomic physics, but as far as I know, this is still just predicted. We just haven't found it yet. I do believe it exists out there. We just haven't found it. I think once we find it, it'll be an interesting thing on how we understand general relativity, how we understand gravity, and the nature of the universe. So I think it'll be a big deal when we find it. Another particle that was a big deal, what they called the God particle. They thought this was part of what helped form the universe. It's called the Higgs boson particle. It was predicted, and they started using numbers even started using it in calculations back in the 1960s. Oops, let me write it correctly, 1960s. They actually found it in a super collider July 4th, 2012. So not that long ago. Science is still finding things. But all of these are fundamental particles. They're bigger than the quarks and leptons, but they carry the force. The force. Now, on this page, I want to highlight some things I want you to know, because this is a lot of information, a lot of weird words. Here are the highlights I definitely want you to be able to know after today's lesson. That there are more than 200 subatomic particles. I want you to know that the fundamental particles are broken up into fermions and bosons. So that's our first split. Fermions are broken up into quarks and leptons. And I want you to know that an electron is a lepton. So it's a fermion, it's a lepton, and that's where electrons are classified. I also want you to know your four fundamental forces. So your gravity, electromagnetic, weak, strong, and what they're carried by. They're carried by the graviton, the photon, the WZ. These are two different particles, by the way, not W/Z. It's the W boson and the Z boson, and the gluon boson, as well as the Higgs boson. Sounds like a lot, but I don't want you to know everything on this page. That's just how it's all broken up. But I do want you to know these. If you're going to go into physics, and especially modern physics, you might go ahead and memorize your quarks as well. So I want you to go ahead and watch the next video on the list, and then we'll come back and we'll talk about composite particles on the backside.